his presentation is open for discussion and questions. Students attending the course are welcome and encouraged to ask.
Is it getting points for this?
Yes. Okay, if there are no questions, I have one. So if you follow your own plan, the last word of your presentation, further increase of temperature to induce desorption of your products. What is your expectation? Which of the products will you desorb first? Sulfur H2 or
usually
hydrocarbon?
usually sulfur have experimentally sulfur have some higher binding energy towards the with the molybdenum surfaces. So I am expecting to remove hydrocarbon fragment first, so at lower temperatures than removing sulfur. So removing sulfur is equally energy required step like hydrodesulfurization process. So during hydrodesulfurization, it is equally known as removing sulfur from the surface, and also the carbon-sulfur bond dissociation. Both are equally rate determining steps.
Okay. If there are no more questions, let's thank Tilan. Oh, okay.
You didn't really mention about your methodology. How you know that what functional do you use, what basis sets, and how you know that this will be valid for your system? Maybe your data are really affected by taking smaller bases, right? If you increase the basis, you will see that this happens not at bond breaking is happening not at 700 but much lower temperatures. Do you have any justification of the methodology?
Experimentally, this reaction is done at around 700 Kelvin, 700 Celsius. So that's why we use 1000 Kelvin. And the methodology, I am not exactly like.
But what functional did you use?
Would you agree that you used PBE functional?
And actually, it was the same question to Zach, right, and to the previous speaker as well. And I'm looking on your reports, you explaining methods, but you're not given any details on methodology, what exactly functional you use and what exactly your basis set, what's the size of your unit cells, and so on. Okay.
Approximately, what is the size of your simulation cell? Approximately, how many nanometers or angstrom?
7 by 7 by 7.
No, nanometers. How big is your unit cell? How big is your simulation cell? Like it is of the order of the thiophenes molecule.
It's in the level of angstrom. It's like about 2 to 3 angstroms. So
the whole cell?
No, it should. I'm talking about the bond lengths of those thiophenes molecules.
But the whole simulation cell, how big is it?
Maybe about 4 to 5 angstroms. Maybe about 4 to 5 angstroms. I'm not exactly.
Maybe a little bigger.
Yeah.
Okay, let's thank Tilan for a good attempt to answer all questions.